Okay, so what are we going to be doing today? We're going to be using a definite integral to find the area under a curve. How are we going to do this? We're going to integrate the function, and we're going to evaluate the function at the limits, because we absolutely don't want to continue doing what we were doing last week. That's a pain in the butt. So I'm using this word integral. And I don't know if we really formally talked about the word integral, but we have talked about the word antiderivative. Antiderivative is just the opposite of a derivative. Instead of going the one way, we're going backwards, basically, right? So an integral is just another name for an antiderivative. Indefinite integrals are ones that don't have boundaries, and then definite integrals are ones that have boundaries. And we'll talk about what's going on with that in a second. But basically the idea, uh, indefinite integrals, those are the ones that give us the plus c at the end. Definite integrals, we're going to be integrating from some number to another number, and that's going to give us a function evaluated at b minus a function evaluated at a. We're going to talk a lot about that as we go through. But basically, the idea is with this one, the plus c is going to end up canceling out, and we're not going to need to bother with it. But this right here, this represents the area under a curve. Just like what we were talking about last week when we had the Riemann sum, and then the rectangles got smaller and smaller and smaller, approaching an infinite number of rectangles. The same thing here. It's basically we're adding up all the rectangles and getting our answer. So let's go through and talk about some properties of integrals before we continue. So here we have three different integrals that are sort of kind of slantwise defined, like, okay, this, whatever it is, that gives you 6. This, whatever it is, gives you -2. This, whatever it is, gives you -5. Fine. Cool. So let's talk about this. Notice the bottom and the top, these limits are the same. So whatever this would have been from 4 to 4, there's no space in there. Anytime we take the integral and the limits are the same like this, I'm going from 4 to 4, the answer to this is 0. Think about it, we've got the integral evaluated at 4 minus the integral evaluated at 4, that's just 0, right? So we don't need to even think about one like this. It doesn't matter what's on the inside here. If you see that the top number and the bottom number here are the same, it's just 0 every single time. Always and forever, amen. So take a look at this one. So we're trying to do it with g of x. But if you notice, here it's from 2 to 7. Here the 7's on the bottom and the 2's on top. We're going from 7 to 2 instead of from 2 to 7. So when we switch the numbers, the top and the bottom numbers, when we switch them, all that does is it changes the sign. So basically what I'm saying is this is the same as negative from 2 to 7, the integral of g of x dx. And we know from 2 to 7, we get -5. So this is basically just -5, which is 5, right? So whenever we take these two and we flip them, and we just change the order of them, if we're going forwards, it's one way. If we're going backwards, it's the other way, basically, right? So one of the ways is positive, one of the ways is negative. So now take a look at this one. Notice there's a little 2 inside here. We're allowed to take that and bring it outside. So what this is the same as 2 times the integral from 2 to 7 of g of x dx. And basically, you know, we already know what this one is, -5. So this is just 2 times this thing that we already know is -5. So here our answer is -10, right? Again, don't think too hard about these. Take the time to just make it look like what these are supposed to look like. Now this is the one that's kind of interesting. This is the weird one, right? From 4 to 7, we don't have from 4 to 7. We've got from 2 to 4 and from 2 to 7 of f of x. Well, what do I do? Well, so it turns out that we can like add and subtract the limits from each other. So if I know we're trying to go from 4 to 7, isn't that the same as from 2 to 7? And then we just cut off the piece that we don't need. So we're going to subtract the part from 2 to 4, right? Right. If I were to take from 2 to 4 and from 4 to 7, I would add them up. That would give me what I need. But here I can do the same thing. I can subtract. Right. You know, I'm going from 2 to 7, and I'm going to subtract this part that's from 2 to 4. I'm going to subtract that out. What am I left with? The part from 4 to 7. Do you get what I'm saying with that? Just basically, we're talking about how you can sort of smush integrals together, separate them out. As long as they connect in the right spot, then you can just sort of smush them together. So, get rid of that. Well, now that I've rewritten this in terms of things I know, I can just do that, right? So I know that from 2 to 7, the integral gives us -2. I know from 2 to 4, this integral gives us 6. Well, what's -2 minus 6? Isn't that -8? Again, don't think too hard about these. I put this out here for it to be intuitive, and it's meant to be intuitive. Don't overthink. Okay, so look here. From 2 to 7 of these two functions subtracted from each other. Well, I can distribute this integral over a minus sign or a plus sign. So what this really is the integral from 2 to 7 of g of x dx minus from 2 to 7 of f of x dx. Right? Since it's g minus f, all under that integral, I can split it up, say the integral of g minus the integral of f. Well, I know the integral of g, that's -5. And I know the integral of f, that's -2. So I'm going to do -5 minus -2. -5 plus 2 is -3. Same thing with this last one. Here, it's a combination of things. I'm doing both this thing that I just did for part E here, and I'm doing this thing that I did for part C. So I can just split this up. I can say this is 8 times the integral, because the 8 can come out. Dx minus the integral of f of x dx. And now just plug it in. I know what this is. So this is 8 times -5 minus -2, right? So what is this? This is -40 plus 2, which is -38. So when you're doing these, always make time to relate it back to the original things that you have. If they have it written sort of implicitly like this, the way that it's written, they don't tell you what the actual function is. They just tell you the result. Always try and get it back in terms of the thing that they give you one way or another. And then it'll be really easy. Okay? So let's do some more explicitly defined things, like right here. I want to take the integral of this actual function explicitly. So remember, the integral of some power polynomial thing is raise the exponent by 1 and then divide by that new number. Yeah? No, plus c. But with this plus c is going to go away when we do everything else. That's why when we do the definite integrals, the plus c doesn't come into it. It's only when we've got these indefinite integrals. But so let's do this. First of all, remember, we can split this up. In fact, I can even do this. Bring the 1/2 out, right? Make life even easier for yourself. Plus the integral of, well, let's leave the 8 in here just so that there's something to be in there. Otherwise, we're just taking the integral of dx, and people get weird about that. But you can actually take the 8, pull it out, and just take the integral of dx, right, which is x. But it doesn't matter. Whatever's more comfortable for you. If you want to write it like this, or if you want to write it, you got the 1/2 x dx plus the integral of dx. You can do either of these written out. It really doesn't matter. It's more about your comfort level. Both of these are correct. Both of these will get you full points on the AP exam. It's just a matter of which one sort of speaks to your brain a little bit better, and that's all. So I'm going to take the integral of x. Remember, raise the power by 1, divide by that new number. So it goes from 1 to 2. So now what we're dealing with is 1/2 x squared over 2, and we're evaluating it from -6 to 8. This little line here with the numbers, that's just a way that people do it. You can do this, or some people, they actually just jump straight to the next step, but you don't have to. I like writing this step out. And the reason I like writing this step out is because it reminds me of what I need to do next. Breaking it down allows your brain not to have to work so hard. So what I'm going to do is I'm going to say, all right, well, let's evaluate it at 8. Let's evaluate it at -6, and then let's subtract them. So we got, I'll make this a fourth, because the 1/2 and a 1/2. Hi there. So I'm cutting in from the recorded video to give a little update on this problem, because I know in class I, for some reason, had an issue. I was getting certain things wrong when we talked about it as the integral versus the um, just like drawing a picture and figuring out the area like a geometry type problem. And so it turns out that the problem wasn't anything else but me being unable to do arithmetic. I can do geometry, I can do calculus, adding, subtracting, multiplying, and dividing, not so much. So just to sort of do it right, 64 divided by 4, yeah, that's 16. Uh, -6 squared is 36, divided by 4 is 9. All the same, 8 times 8 is in fact 64. But then -8 times -6 is in fact not 42, but 48. Yeah? I think I said something like 42 in class, which is why our answer was 113 instead of 119, because I was off by 6. Hey, so, you end up with 119 when you add all of these together. And to sort of talk about it again in terms of the geometry type thing that we mentioned, you can actually draw it out so that it's an actual thing, and you can like, hey, this, I know how to graph this as a line. Let me look at it visually. Yeah, close enough. So there's my axis, and then I'll make each of these like 2. And then so I want to go from -6 all the way up to +8, 2, 4, 6, 8. And then find the y value. Well, at -6, if I plug it in, I should get 5, 2, 4, 5. If I look at 8, I should get 12, 2, 4, 6, 8, 10, 12. And then if we go through and we draw the picture, hey, this is a trapezoid, and I want to find the area of this trapezoid. Well, I know the formula is 1/2 times the sum of the bases times the height. Well, the height here is 2, 4, 6, 8, 10, 12, 14. And we did this one right in class, and I was looking back on it kind of sad that I screwed up the other way. 2, 4, 6, 8, 10, 12. So again, 1/2 times 17, 5 plus 12, right, times 14. And if we multiply all this out, 17 times 7 is in fact 119, because 70 plus 49. So my statement does stand. As long as you know what you're doing, and if you do good arithmetic, let's put that in there. As long as you know what you're doing, and as long as you do things that make sense and you do logical things, it doesn't matter where you're coming from. It doesn't matter if you're I think I'm in the way a little bit. There, move me down a little bit. But as long as you have a concept that you can bring back and you can logically talk about it, you can do these in pretty much any way. Like, if I don't know, if the rectangles made sense to you the most, then you could use that, although that's a lot of work. If doing it with an integral helps, if you end up realizing, hey, my picture is a shape that I know how to find the area of without having to use calculus, you can do it either way. So there we go. See you later. Like here, this is actually a half circle. If you were to graph this, first of all, what this is, you've got y equals the square root of this 4 minus x squared thing. If you square both sides, x squared plus y squared equals 4. This is the formula for a circle with a radius of 2 centered at 0, 0. So the thing of it is, you could, if you had no other recourse, which here we really don't, I haven't taught you any better yet, you could say, all right, well, but this is the top half, right? This is the top half of a circle. This is a semicircle with a radius of 2. Well, what's the area of that? That's what this is asking anyway. What's the area from -2 to 2, right? The whole thing? Well, the radius is 2 for pi r squared. And be like, okay, well, 4 pi, ain't it? But we only want half of it. So divide by 2. This is a semicircle. You don't want just the whole thing. You want half of it. So 4 pi divided by 2, what are we left with? 2 pi. So this tells us what our r squared is, right? If we see this as a 4, then we know our radius is 2, and since it's the square root, we know it's the top half. Or, it could be the bottom half too. It doesn't really matter. You'll get the same answer either way. So whenever you see from -a to A, I want to show you guys sort of the general format. Whenever you see this, the answer is 1/2 times pi a squared. Automatically. If you see this, you don't have to go through the whole problem of trying to figure out how to deal with that. Nobody's going to make you. You can just use this and then be done with it. I'll tell you right now that it's going to come up again and again today. They're going to throw that at you, and the expectation will be that you find the area of the half circle that they give you with using this to find the radius. Just what number squared is this? And that's all. So let's continue. Here, one like this, I want you to be very careful with, because absolute values have a sharp corner in there, and that makes it non-differentiable. Like you can't just take the derivative of this like normal, which or the integral for that matter like normal. What you have to do is you have to break this up, because 2x before the vertex, when you've got absolute value, is actually a negative 2x, right? Because if you look, and then when you've got an absolute value function, it's got a sharp corner. On the left-hand side of the vertex, on the right-hand side of the vertex. So we're going to have to basically do this in two separate places. Since the vertex is at 0, we're going to split this up from -4 to 0 of negative 2x dx plus from 0 to 5 of normal 2x dx. And this is actually going to be easy, because when we integrate this, we're going to get -2x squared over 2, right? Because the x goes from to the first power to the second power. Then we divide by that new exponent, and we're evaluating from -4 to 0. We're evaluating from -4 to 0. And then we're going to do the same thing here so now we've got positive 2x squared over 2, evaluated from 0 to 5. Well, so now we do this. Well, when we plug in 0, we know that that's going to be 0, right? And these 2's cancel out, so we're left with negative 4 squared. So -4 squared is positive 16. Right, that this one cancels out, so we're left with these two, and then these two negative signs cancel out. So this part's 16. Now let's do the other part. Remember, you don't have to do the whole thing at once. In fact, I recommend you don't, because that's a pain in the butt to do. And again, these 2's cancel out. So we're just left with x squared. Well, what's 5 squared? Then minus 0 squared, right? Well, what's 5 squared is 25. Minus 0. So we got 16. We got 25. Together, that makes 41. And again, if we could turn these into triangles, right? 1/2 base times height. So we've got this triangle, base of 5, height of 10, 1/2 5 times 10. Well, that's 25. Here, this goes up to -4, so this has a base of 4 and a height of 8. Well, 4 times 8 divided by 2 is 16, which is what we got here, right? So you could do this differently if you wanted to. You don't have to do it differently, but like if you want to break it up into what you remember from geometry, do it. You'll get the same answer either way. I keep telling my geometry kids, and I'll say it to you too, when you have a problem, it doesn't matter how you do it, as long as what you do is logical, it makes sense, and it comes out to be the same answer. But you can go from any direction you want. There are like 1,000 different ways to tackle a problem. The only thing you have to do is make sure that what you do makes sense, and then you should get the right answer. And like in that problem before, I'll sit down and figure out what I did wrong. But obviously, I screwed up somewhere. Maybe I misjudged something, right? That's fine. It happens. So here, and I want to point out this one again. This is the same thing. Split it up so that you don't have to do too much at once. Plus is x squared. And remember, this is a half circle with a radius of 1. So you can stop having your brain like think about this one and just move this one right to right. So this part ends up being pi over 2. What about this part? Well, we're going to do 3x, right? The absolute value of dx becomes x. And then we are evaluating from -1 to 1. So we've got 3 minus -3. 3 minus minus, so this is 3 plus 3. So we end up with what? We end up with 6 plus pi over 2, and I would leave it here. I wouldn't do anything more than that. I would just leave it right there. Nobody cares that that's 7 point something. It doesn't matter. That's a good enough answer for me. And a good enough answer for the people you're doing the AP test with. All right, so take a look at this part. So what we can, and again, break it up, make your life easy. The integral of this one, 9x cubed over 3, so 3x cubed. The integral of this one, x squared over 2. The integral of this one, 4x. And again, we're taking this and we're evaluating it from 0 to 6. Well, when I plug in 0 for all of these, I can just get 0 back. So it's whatever I get when I plug in 6, right? So 3 times 6 cubed. 6 cubed is 216. 4, 6. So this is 648 plus 6 squared, 36, divided by 2, 18, minus 4 times 6 is 24, and minus this whole thing is 0, right? This whole part, I plug in 0 for any of these, I get 0. So again, don't do too much. You're allowed to do what is simple and easy. So we got somebody's not going to like that. 6. And we're going to subtract 24. There we go. And so when we integrate this, we get 642. Final answer. All right, let's do a couple more. So I want to point out the directions here. They're going to be like, okay, we'll do this. We know how to do this already. This is what we did on Thursday. Ain't nobody got time for this. We know how to take a definite integral. Take a definite integral. We got 3x cubed over 3, so the 3's cancel out. We got minus 2x squared over 2. Those 2's cancel out. Plus 4x. So let's rewrite this so that it looks nice and neat. We're evaluating this from, not from 0, from 1 to 4. And so let's do that. 4 cubed, that's 64, minus 4 squared, that's 16, plus 4 times 4, that's 16, minus, now we're going to evaluate it at 1. 1 cubed is 1, minus 1 squared is 1, plus 4 times 1 is 4. Okay, so let's simplify this. 64 minus 16 plus 16, that's 64. 1 minus 1 is 0, plus 4 is 4. So 64 minus 4, our final answer should be 60. Whenever you get a direction like this with me, you don't need to do this. And guaranteed on the AP exam, you're not gonna see this. I can think of one problem I've seen in the past God knows how many years where they've actually asked you to do this. Don't. You know what I would do if it were me? They would say use the equation this, and I would say as n goes to infinity, the limit of blah 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 approaches the integral from a to b of this thing. You do that, and if they take off any points, I'll yell at them because that's not fair. There's no reason at all.